Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. It is time for us to actually I don't want to say use, but have some fun with, I guess. We made a memory visualization so we could see how we were using memory in Handmade Hero. And the reason I wanted to do that was because our entity structure is super piggy, and that was intentional. We just don't care about it right now. But I would like to move into a phase of the project where we do care and have some idea of what we're doing with that. And in order to do that, I wanted to have a memory visualization we could look at just to have some idea of what was going on there. So, just to, I guess, give some perspective on where that was at for people who may have missed it. That's not how you spell remedy. What we want to do here, also, I think I'm behind on my remedy. You know what? Pause everything I just said. Do we need to update our debugger? How do I update my debugger? Update my debugger. Download. I don't know how to use this thing. I don't know. I've never known how you're supposed to use this thing. All I know is I had to use it to get remedy, so I did. Is there a remedy? There we go. Remedy.itch.io. Alright, so I want to say there's been a fairly major update. Yeah, 2.7. Alright, so let's get that going. I think it has some good features in it too. He added a cut and paste for us too in the watch window, just based on what we were doing the other day. He was like, sorry, there wasn't one. I added one for you. So George always adds so much stuff for us. I want to always keep up to date because he's been so great about updating it with new features whenever we run into stuff. So yeah, just wanted to get that going. Okay, so let's try that one more time. Rewind. Now let's start Remedy 2.7. And you know what it also has that's pretty awesome? Check this out. It's got this new layout feature where you can save all your window layouts in here and like switch between them real quick. So you can just like pull back, oh, I want layout 0, 1, 2, 3, and I can name them different stuff. So if we want to have like a memory inspection one versus like a threading one, you can create different layouts and switch. And that seems really cool. I don't know how much I will actually use it because I've always kind of just stuck with this layout. I mean, Visual Studio's crappy, and I don't think it lets you switch layouts very quickly. So I've never really thought about that, but maybe we can try and think about that and start to add stuff. I do suspect as Remedy becomes more powerful, there will probably be other windows too and stuff like that, and then it really would make sense too to be able to have a bunch of different layouts. Either way, I thought that was pretty cool. So anyway, I'm going to go ahead and open up Handmade Hero and just show you what I mean about the memory layout stuff. So what happens now is, we've got these like debug things. I'm hitting the F keys, right? And you can see it switching between those. And so if we go to the memory view, what it allows us to do is see which arenas exist in the system currently, and we can name them. So here are some that have never been named, and I don't know that we care that they were because it's only 1 megabyte, but maybe for completeness someday we should name them. But then you can see here we've got, for permanent storage, you can, for carrying, allocations throughout the game, you can see that we've got 69 megabytes in use. For the game itself, we've got 279 megabytes used for just asset backing storage, which is just bitmaps and stuff we keep in there for sending down to the textures and sounds and that sort of stuff. And then finally, we've got the debug that's taking up 135 megabytes. So we don't care about that one because that's just storing old like debug information in case we want to. It's basically like all of that memory arena stuff, but then also like this stuff here so that we can pause frames and and look at different pieces of debug information, right? So we don't care about that because that's not really relevant to our game's performance. It's because it goes away entirely. But the part that I'm interested in talking about now is this part here, the 69 megabyte number. Now, 69 megabytes is child's play on any modern computer. You know, the Unreal Engine game is probably a 69 megabyte executable, let alone the game. But that's not why I'm interested in it. The reason I'm interested in it is, remember, our game is very minimal right now. We have only created a small number of entities, and we want to be able to create very large worlds here. And so I want that number to be fairly small so that I know when we create a world that has 100 times as many entities in it as this one, or 1,000 times as many entities in it as this one, we're not going to be in really big trouble. And right now, we kind of would be. If we wanted 1,000 times more entities than we have right now, which granted maybe we wouldn't necessarily get to because that might be just too big of a world for anyone to ever play, but that would be, what, a 6 gigabyte, if I'm not mistaken. Is that right? I don't know how many that would be, but, well, it actually, no, if it's 69 megabytes, if I do 1,000, it'd be 69 gigabytes, right? And so that's just not feasible. And so even 100 times would be 6.9 gigabytes or 7 gigabytes, right? So you can see why that's a concerning number. I'd like to be able to get this down to something smaller and more manageable. And if we look at our memory visualization here, what you can actually see, we can hover over these guys and see who allocated what and why. What you can see here is we have a bunch of things down here that are probably pretty uninteresting, right? You can see that these are like the asset rendering allocations, just some basic stuff that got allocated down here. We could go figure out what those are at some point and take a look at them in more detail as necessary, what those arenas do, and so on. But we probably don't really care about this very much because this is the big block here of all of our world data. And that's really what we care the most about because it's the thing that's going to scale up as our world gets more complicated, right? So if you take a look at what we've got here, you can see that each one of these things is sort of a fixed size chunk, and there's a really good reason for this. The reason why each one is a fixed size chunk is because we store our world in fixed size chunks. So we pack entities into fixed size chunks and bucket them away for future reference, right? And so each one of these chunks is a little storage for what's being kept in some world data somewhere. That's what's going on, right? And so you can also see we've got kind of a bug here, or at least something that's a bit inefficient. You can see that each one of these things is about a 64K chunk, and the last one in every block is like fallow, right? There's nothing in there. And so you can see that either we have a bug or, and I don't really quite remember exactly how we did this, but this may be how we did it. When we did our, we have a block storage thing that we used in the platform layer to like record like pieces that got allocated. It may be that we can't store the last 64K because a little bit of it's used by that platform layer, right? And so you can kind of see that that creates a nasty wastage situation here. And granted, that wastage might go away if we turned off whatever memory tracking is happening down there in the platform layer, but that is something we may want to address at some point just because we'd like the game to run basically memory profile-wise in mostly the same way as it would be in terms of layout inside blocks during shipping and release. So that might be something we want to take a look at fixing at some point if we can. But none of that is really all that relevant. The more important part here is looking at how many 64K blocks are actually necessary to store our current entity load. Now, there's one thing that I think we want to do before we go any further, and that's just to improve this visualization slightly. And the slight improvement that I want to do is right now we do not differentiate at all between block sizes. They're always drawn exactly the same, no matter how big they are. Now, what do I mean by that? Well, take a look at this here, right? This block is one big allocation that somebody allocated. You can see it's in Handmade Asset Rendering allocated it, right? It's on 178. Let's just go see what that is, right? Let me load up 4Coder. And if I load up Handmade Hero and I go to 178 in Handmade Asset Rendering, here you can see us pushing some lighting data. And so this piece of lighting data is what that entire push is, right? And you can see that it's written out in bytes. It is, what is that? We should probably put some commas in there, huh? But that is a 1 megabyte block, it looks like, right? About a 1 megabyte block of data. Okay, so that's a 1 megabyte block of data, and this is a 64K block of data. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 of them, right? So maybe 16 times 64, they happen to line up. In this case, they do. So these are the same size, and this visualization is accurately representing the difference between this block and this block, right? Like, they're the same size. This is the same size relative to this as it should be, right? But if I'm not mistaken, there's no real reason for that to be true. And I don't know if I can actually find a block here where it's not true, but we didn't enforce it. So we could just keep hoping that nobody ever changes their block allocation size. But if anyone ever allocated a super block, right, the huge sub-allocated region, if anyone ever allocated one of those that was bigger than 1 megabyte or smaller than 1 megabyte, this wouldn't line up anymore, right? In fact, that's a good example of it right there. So these two blocks, although they are the same apparent size on the screen, are totally different sizes, right? So that one right there is like 1.7 megabytes, and that one right there is 1.1 megabytes. But they're the same size. You see what I'm saying? And again, I think that's just because the default allocation is 1 megabyte. But whenever you allocate things, it's going to allocate a megabyte block and subdivide it up for you. But if you needed to allocate something bigger than a megabyte, it just allocates a special allocation for you, right? Here's another example. There you go, right? That one's 3.1 megabytes. So again, that, and that are all drawn exactly the same size, but they're totally different size allocations. And so while this does let you know one piece of information, which is how each block is subdivided accurately, meaning this does show how much of each block is used correctly. Any given block size is not proportional to how big it actually is. And so what I think we want to do before we go any further, just because we only just finished this memory stuff last weekend, we just only barely got it working at the end of the stream. We were like just finishing up. And I went long to do that. What I'd like to do today is just get our memory view into some more stable state where it's properly drawing things at sizes related to their total absolute size, so that we don't have to inquire explicitly all the time to make sure that we understand the sizes of things. And we can also potentially just treat this thing as one giant like grid, right? And sort of place everything so that we know, one row is 4 megabytes always or something, right? So we can kind of see, we could even draw in markers that are like, here's 64 megabytes, 64 megabytes, 64 megabytes, right? So we can kind of get that that understanding more directly. And you can kind of see too why this is important. Like if I go over here, you see this asset storage arena's got 5 allocations, right? That's a total number of allocations that are in it, I think. Oh wait, no. What are these two? So that's the total number of allocations. I forget what these actual numbers are. We're gonna have to go back and look. I don't even remember what they are. I think it's the total number of blocks versus total number of allocations, I think. So it's something like 67 blocks with 1,077 allocations, 5 blocks with 1,178. And so one of the things that I look in here and I see, I don't really understand what I'm looking at here either, because if I go through here, I don't see, like, I don't know where that asset storage block is, but I guess it's this one. We need to make those tooltips not go off the screen. Like, I can't see what that is. Hold on a second. We can cheat that though. So you can see there, and I don't really, again, I don't understand why that looks like it does. So this is something we have to kind of we have to look at, right? If you look at the asset storage arena, just looking at it here, I mean, I only see, like, what? 1, 2, 3 allocations total, right? And so I don't understand, well, 4. Okay. I don't understand why, when I look at asset storage, if I only see, you know, if I only see a few allocations and yet it's telling me there should be 1178 of them, what's going on, right? So something's a little bit wonky there as well. So I feel like that's what's on tap today. Get this thing into a good solid state, make sure nothing weird's going on, and then from there, tomorrow we can start on the entity stuff that I wanted to do, which again we need for lighting and ground cover, just to improve the quality of the visuals there. So I'm going to go into the debug system and just take a look at that. The first thing I'm going to do is try to look for why we're not seeing all of those allocations. I don't remember what this is, but I guess it was around the profile bar stuff, right? Yeah, here it is. So if we look in here, we're not drawing suppressed arenas. And so I suppose it's possible that somehow those arenas got labeled as suppressed, but I don't think so, because again, we are seeing it show up. So it couldn't have been suppressed because we're seeing it show up. We're just not seeing enough of it show up. So here's us looking through each allocation, and here's us trying to plot that allocation as various rectangles. So maybe, you know, is this loop busted? You know, what's going on? Let's take a look and see what's going on with this part here, and why that's wrong. So what I'm going to do first is I want to look at the memory lister, because essentially what I've got is two things that disagree. And so I should be able to compare these two things and get some idea of what am I doing differently between the two. I must be doing something differently, otherwise I wouldn't be getting different results, right? All right. So let's start by looking at the loops themselves. What you can see is that in both cases, we loop over the arenas in order. This index here, I'm not sure what we're actually using it for. We're just using it for sorting, right? So we're not sorting anything in here, so we don't need that index, right? But otherwise, these loops are the same. We check for suppression here because we don't draw suppressed arenas, which makes sense. We shouldn't really be looking at the outlay of those anyway. And we couldn't, because any arena that's suppressed, we don't record the exact locations of blocks. So while we could draw just the blocks themselves, which maybe you could argue we should, in fact, we could just let those draw, because we do record how big the blocks are, I think. Let's do that. Let's just try that. I mean, hey, we're in here improving this thing. Let's see what happens in that case. So what I'd like to do here is say, all right, we're going to push these rect outlines here. What I want to do is take that arena suppression, and I want to take the arena suppression and move it down to the place where we're actually drawing the subblocks, like so. And so the subblocks there will tell us effectively, like, you know, where all of our suballocations are. In a suppressed arena, we don't know those, but we should still know how big they are. So what I'll do here is say, well, we've got this color for the overall block, right? And that's what we're drawing the sort of, you know, gray to indicate, you know, that it's a block that's, you know, been allocated and maybe not all of it's been used. We'll see that gray show through. So what I'd like to do is say, well, if the arena is suppressed, so in other words, if this happens, then I'd like to change the color to something else. And so what I might do is say, well, in the case where the arena is suppressed, maybe we make a much darker gray. So we know that just, hey, there's some blocks being allocated here, and we can't really do anything with them. And they're not relevant to the running of the game, but we're still going to show where they are and that they were allocated, right? Just so we can visually see them and know that they're there. So if we take a look at the arenas now, just looking through, so I don't see any of those, but I don't know if that's because there's something weird about the suppressed arenas that doesn't allow me to draw the blocks, or if that's because, again, we've got some kind of a bug where, you know, we're not seeing the asset allocation arenas working properly either. So again, I don't know what to make of that. That could all, you know, be more part of the problem as well. But anyway, so I think I want to draw those if I can, and we'll see if there's a way to make sure that that actually works to some degree. So let's go ahead and keep going here. So normally what we then do is we loop over the blocks that are in the arena, and you can see me doing that here in a sort of a block and allocation sort of phase there. Looking at this, let's see. So assuming that the arena is not suppressed, the looping over the blocks looks exactly like it normally does. Looking at the allocation, that also looks basically the same. We're tracking an allocation index here, but the only reason we're doing that is to pick a color from the color table, and that really shouldn't be an issue, I don't think. It's an unsigned integer, and it's getting modded by the size of the table, so that should just roll, and I can't see any reason why it wouldn't. So looking at this stuff here where we're trying to draw them, it could be that something's wrong with the way that this is being computed. We'll have to take a closer look at that a little bit later. But otherwise, I'm not sure why we would be having a problem here. So what exactly is this text buffer add line situation? So you know what else I'm wondering? When we're adding these rectangles, is it possible for us to run out of graphics space? Yeah, I'm not sure. Well, anyway, let's take a look here at just that tooltip thing. I want to take a quick look to see what happens in there. So looking at the tooltips here, well, actually, but that's okay because this only happens if you actually hit the rectangle, so that's fine too. So I don't really see any reason why this shouldn't be drawing everything. And yeah, and so I don't know. I don't know what to make of that. At the very least, I would think that we should see the blocks showing up for the other arenas that we're not seeing. And I'm not really sure why we're not. It could be because also maybe they're too small, like each allocation is too small compared to the size of the block. I'm not sure. But let me just loop through here really quickly. And what I want to do is take a look at the arena names there, basically, and see if what we are actually trying to draw, and if it looks at all sensible. You know, I need to look at the names of these here. I just want to see if it looks at all sensible when we draw. Well, you know what? Why don't I just jump to draw arena interval? There. So when we're drawing this, I'm going to go to each arena here and see, you know, because they've got names associated with them. Oh, I guess I've got to be in debug mode there. I never understand why I restart when you could just, I don't have to restart. I could just build in debug mode, but, you know, I never think of it. Let's try that again. So if I click on arenas now, and we look at the names. So here's the debug arena, and this should still draw some blocks, right? Because even though it's suppressed, we should do these two. We won't do this interior bit, but we should still draw this rectangle. And so my question is, like, yeah, what's the block rectangle that we're drawing in this case? And so that looks like a totally valid rectangle to draw. Right, I mean, and we should have been drawing that in the sort of darker block color as well. So why aren't we seeing that? Because that should have shown up. We're drawing it in a legal location, as far as I can tell. That certainly looks like a reasonable location to draw it. And in fact, let me look at the profile rect itself, just to see what the min-max is there. I mean, that just looks like exactly like what you would expect, right? And so I would assume, you know, I think I should see a sort of darker gray rectangle as the first rectangle in the set, right? It should be like right here. There should be like a dark gray rectangle right there. And that's definitely not what I'm seeing. We start off with the Handmade world. It's not even the same arena. You know what I mean? So I've got a drawing bug here. Like maybe my block Y calculation is screwed up and I end up like overwriting where I was or something like this. Do you know what I'm saying? So I've got some issue there that just doesn't add up. So first things first, this block computation has to be outside the if. So that's probably all that was. That makes good sense. All right. So that should fix the problem of why we weren't seeing the debug blocks. Now we should see the debug blocks because I just wasn't incrementing the block counter when the arena was suppressed. Just a typo when we added that, when we reorganized that loop boundary. So if I go in here now and look at the debug version, right, there you can see, and you can actually see it adding, right? That's it. You know, we stack up a certain number of frames of back debug information. Each one of those is sort of like showing you that we're recording more and more back information until eventually we stop recording because we hit our size limit, right? So that's what's going on there. Doopy-doo. And normally that gets hit more quickly, but because we're in debug mode, right, the frame rate's very slow, so it takes longer to accumulate. I don't remember how many frames we did, 128 or something like that. And so it takes longer to accumulate all of those frames. We're probably going to have to make this scrollable too, because if we want to see all of our memory and we want to draw the debug, which we could turn on and off, would also be a pretty reasonable thing, like to have a setting here that was like, one of the settings is, do you want to show suppressed arenas or not? And that seems like a good idea as well. So we should probably do that. Let me see if I can do what I wanted to do now, by the way. It's just compile in release mode. Yeah, so you can just switch between release and debug, no problem, which is nice. So yeah, like you can see, like we're gonna need some way of like scrolling around this probably, which is no big deal either. But you can see like all this huge block of debug information that we just have allocated here, right? And that's the debug arena. And then we got all our other arenas. All right, so that works fine now. And maybe let's add a toggle so that we can get rid of that just in the short term. And we probably want that to be the case in general as well, because, you know, if we don't probably want that to be used in certain cases. So we know that there's, we've got sort of this idea of storage for our different, like here's the profile graph, for example. Here's the arena view. So we could have a thing here that's like, hey, show suppressed or not, right? And so what we could do is when you get called in here and you've got that graph ID, I want to say that dev UI there can now access this information and have like basically a switch that turns it on and off. That's my story and I'm sticking to it. Is that true? I don't actually know if that's true or not. Well, it's not. It's this thing. It's the graph ID. Is that graph ID used anywhere? You know what? That may not actually be used anywhere. But surely you would want to use it sometimes. Like, don't you want to know that information? Draw profile bars. Total clocks. Well, I think we may have to pass it down then. I guess, I don't know. I'm not really sure how we were meant to recover those because it's been too long. But when we actually draw these, we have that graph information. And I guess we just don't pass it down, maybe? I'm not sure. But if you look here, right, when this gets called, you can see that we have the graph available here. I guess we just don't send it. But I think we want to because it seems like something you would want to have. Right? So I feel like we want these folks to have access to this graph. And so in here, we would just want both of those to be able to look at it, because that's where we would put settings about what to like include in our various memory views. The example being whether or not suppressed arenas show up, but there's other reasons why we might want to put that in there, right? All right. So what I'd like to do here is say that inside this, we want to look whenever we're going through this this bit here. I guess I want to suppress the entire operation of it. So I want to kind of do like don't do anything. If the arena is suppressed, and show suppressed isn't on. So what I'm going to say is if it's not suppressed, run it, or if suppressed is on, run it, right? And then the same exact piece of code would be used up here. So when we get into one of these, we would just suppress like that arena entirely and not even draw the blocks if it's, you know, got that turned off. And so then we just need some way of allowing the user to actually choose whether or not it is or isn't. And so we need to put a button in there that basically says like suppressed or non, you know, show debug or don't show the debug stuff. So yeah, if I look for draw top mem list or whatever it's called there, in here we just need one of, well, there's the Boolean button right there. So what I want to do here is say, let's add another button, and that button is going to be like debug or something. And what I want to do is have graph show suppressed, and that itself is the Boolean we're talking about. the interaction is going to do what here? Well, actually, so I don't know that it's, well, I guess this is fine. So it's just going to take our show suppressed and it's going to toggle it, right? Is all that's going to happen. So we just want it to be like not show suppressed. I think that's all we actually need, right? I think. Oops. I meant graph. So all I'm trying to do there, again, is just have a way of controlling whether that just shows up or not in case we're interested in it. And so then when we go here, you know, the hope is... Oh, well, that didn't work very well, did it? Oh. So it looks like I don't actually count the arenas in that loop. I assume that all the arenas are actually there. And so... wonder how I want to modify that. So I guess the way I would do it is say, well, we do the arena count here, and then I guess what I would probably do is actually have the arena count get set, so whatever the index ends up being here, I would set the arena count to that. So when we're done, I would just say like arena count equals index, so that we get rid of the ones that we're not using, right? And of course, I actually need to do this. Oops. This has to only happen when we use the index. I could do it like that as well. So I think that's good enough for that, and should take care of the fact that we were using some arena, we were using some things in our index, our sort, that never got filled in. So if I include the debug arena, you can see that it pops in there, right? And the reason I wanted this in both, because you're saying like, well, why would you care if it was included here? These percentages are based on the total that gets used. So if I turn on debug, it changes my percentages, right? Because it includes the debug in there when it calculates what percentage is getting used. So having debug be off computes the percentages for the actual runtime of the game. And lets me see that, like, okay, 80% is in the asset storage, 20% is in the game entities, right? And that's better. That's a more useful heads-up view. If I go into the actual arena layout view here, same thing is true, right? I can now see the with or without the debug, and that's nice. Okay, so problem number 2. Now that we've got that out of the way. Why are we not seeing assets or allocations from the asset system? Why are we not seeing them show up as multiple blocks in here, right? So there's a couple things that could be happening, and I have no idea which one is. It seems unlikely that the thing I'm about to say is true, but we're going to say it anyway. In fact, I know it's not true. Just looking at this, just looking at this, I can tell it's not true. So never mind. So let me say what I think the problem is just in general. So looking at this, again, I'm worried about the difference between these two. You know what I'm saying? I look at this and I see this allocation number, and I look at this and I can't find, where are they, right? They're just not, what's going on? And so something isn't adding up, and we need to find out what it is. So in here, trying to think of like what the best way to approach this would be. But if I go into the draw top mem list there, and we just look in here at like what is the actual stuff when we're tracking these allocations. So when we print this out, we print out the total number allocated and the total number used. Is that right? What does that mean? So allocated is blocks, right? So this is the total number of blocks, which is what we thought. Maybe I'll do this. Right. So now, just to underscore this, right? And that's not a very pretty printout. Maybe we can just put it at the top. In fact, that seems better. Why don't I do that? Take this thing. And then put it up here. I've got to advance the line, don't I? Yeah. I think we have tools for doing this text out now. I should probably be using them, but, you know, oh well. So if I want to just take this and print a header here, what I want to do is keep this formatting, essentially. And so what I need to do is say, well, we were previously doing 4 spaces, 1, 2, 3, 4, right? And then we had megabyte, which is 1, 2, and a space. And then we had some number of percent here. So 05.02 is 5 total spaces for it, right? So 1, 2, 3, 4, 5. Then we had a percent sign, that's 1, and a space. Then we had 4, 1, 2, 3, 4. And then we had 1. And then we had 8, 1, 2, 3, 4, 5, 6, 7, 8. And that's the total width, right, of the thing. So if that's the total width, oops. Oh, I guess with virtual white space, I can't really line those up, can I? That's a bummer. Well, let's try this again. So if that's the total width and I want this to be lined up, I can just do like blocks and allocs, right? Something like that. And that way we can just see what the heck these things are, because otherwise I don't know. Oops. What did we do wrong? Allocated undeclared identifier. That's a good point. None of this stuff should be there. There we go. So again, this is just me trying to make it so that we won't accidentally misread those or forget what they refer to, because 2 months from now we're going to be like, what was that? All right, so I just need to push those forward a bit. Yeah. So much for my poor counting abilities. Something like that. If you really want to get fancy, you'd add columnar displays here, so you could just sort of say, like, here's the table and here's the headers, right? We're not going to do that, but you could. All right, so that seems better. Now you can kind of see where those are and what they refer to. Maybe I'll move it back a little bit. And call it a day. And so now we have to go to do the actual debugging to figure out what's going on here and why we can't sort of tell why we're getting so many allocations recorded and what's happening. So one of the things that I would like to be able to do, and right now I guess we don't super have a way to do this, it would be nice to merge by string where these allocations are coming from. And we don't really have a way to do that right now. Like we don't have a little string combiner, basically, like a little string hash thing. Although I don't know, for all I know, maybe we do. We have a lot of stuff in here. Doesn't, well, so we sort of hash by string sometimes. And using debug elements, I guess, we do that sometimes. But it would be nice to have something where we sort of summed up by string which ones are which under each arena, because every arena has some number of call sites that are, right, like there's some number of call sites in our code, and each one of those call sites is responsible for some subset of the allocations. And when we look in this mode, we can see that by hovering, but when we're in this mode, we actually can't, right? So this just says the arena, but we have no idea, like, we have like no idea who is responsible for each one. By the way, I want that back 1 and over 3. I don't know if that's quite right. We'll find out. Yeah. So yeah, I mean, I'm tempted to just say, like, under each of those, we should just list the call sites. So that when we print it out, we then just list, like, for each call site, here's how much memory was allocated, how many calls to that call site, how much memory allocated for that call site, right? And so, like, I am tempted to just write a little thing in place. And again, this is the place where, like, C and C++ are just always crappy. You have no choice but to use some super terrible templates or something if you just want, like, a generic way to hash strings. They just don't have good metaprogramming support, so it's always a pain in the butt. To use any kind of generic structure, it comes out horrible. But I'm tempted to do something here where we can just keep track of this in a trivial way. And thankfully, like anything else in C, writing one from scratch is actually quite simple, so it's no big deal. But if we want to do this, we could just say, all right, let's just create a, well, in fact, the debug memory entry might actually be what we want. I'm going to move that out here. It's not quite, so I'm going to make a different one. So this is our, like, debug memory call site. And I'm just going to say that we've got some way of referring to, like, the name of the call site. And that's just going to be used for coalescing. And then I've got just a single statistic that's like the amount allocated. So this will track the number of bytes and the number of calls from this particular call site, right? And so to do this, there's not really a lot to it. All we have to do is every time through each one of these things, as we're seeing these call sites stack up, we can just remember them and put them in here, right? And since I'd like this to be per arena, and I'd like that to be true even if because, like, remember, call sites in code, the call sites themselves are, I'm not sure how to say this. So an arena is an actual thing that exists in memory, right? We have a pointer to it, and it's like a chain of like blocks that gets suballocated, right? So a single physical location in the code, like a single line of code, there doesn't have to be a one-to-one mapping between that line of code and the arena it's using, right? Because a single line of code could just have been passed which arena to use for its allocation. So that means I've got two separate things I'm trying to track. There's the arenas and there's the call sites, and I want to print out how much each call site contributed to each arena's allocations. So I want to do this multiple times and record separate entries for each call site per arena. Make sense? And there's really two ways I can do this. and I don't really know that I care which one I do. So I guess I'll just do the more stringent one first. So I'm going to stick the arena in here, and I'm going to stick the call site next pointer in here for hashing purposes, right? Then I'm going to go ahead and say, give me a hash table, because why not? And so right at the top here where we're taking temp memory up, I'm going to say, give me an array of pointers to call site things, right? So there's my call site hash, and I'm going to, yeah, I don't know how many there's going to be. Let's say call site hash size is 128. Then what I'm going to do is say the debug memory call site with no clear. Well, actually, I do want that cleared. So I want pointers to those. I allocate that. And off we go. Each time I come through here, when I see a particular type of allocation, what I want to do is now look up in my hash table to find that allocation. And I want to find it keyed off of not only its call site, but also which arena was responsible for that particular allocation, so that I match it to the correct one, if that makes sense. So what I'm going to do first is I'm going to compute its hash value. And I don't know, we've got a string hash here somewhere, so here it is, right? And these allocations that we've tracked, they've got the GUID right here. And to be consistent, I suppose I should also take a second to make sure that this is named GUID, because name is probably not right. So if I take the string hash of this GUID at the time when I'm actually doing the summation, then what I can do is look it up in my call site hash, and I can just try to find where it goes. So I need to mod by the call site hash size, and then that gives me my hash value, or really it's the hash slot index, right? And so then I say in my call site hash, I loop from there and say for each one of these things, I might call this test. I'm just going to see if I can find a match. So I'm going to say if the arena equals the arena that I'm talking about right now, and the GUID equals the GUID I'm talking about right now, right? So I need to do a strings are equal here. But since these GUIDs come from a unique call site, really I don't have to do that. I don't have to actually test for equality there. I can just compare the pointers because they're the same, right? I'm going to track the actual pointer to the string, so there's no need to compare them. I can't have two places that generate the same string but different string pointers. That's not allowed. In fact, we go out of our way to prevent it by inserting a counter into each GUID to prevent this very thing, right? So if this is correct, then what we want to say is, hey, we found the thing, right? So we'd say we found it, done. So that allows us to collect, anything that's already in the hash table. And so if we didn't find it, we just need to create one here. If we did find it, which we will have at this point, we just now need to make sure that we record into its allocated exactly the same thing we were doing here. So we're just going to do this statistic twice, but instead of going into this one, we're going to go into this one instead, right? So, excuse me, that allows us to accumulate for call sites as well as arenas, which is what we wanted. And so then in here, when I'm looking and I don't find a site, no big deal. All I have to do is push a new one on, right? And remember, we're in temp memory here, so we can do whatever we want. I can just do a push struct onto that temp arena, and we don't care because it's all going away in a moment. So it's no harm, no foul. Okay. So I'm going to push struct on there. I know that what I want is one of these debug memory call sites, and I know that I don't really need to clear it because, well, actually, I might as well because I got to clear out the statistic. It's fine. So I'm going to push one of those on, and then I'm going to set it up correctly. So the next in hash is going to be the call site hash for that hash site, right? Like so. The arena is the arena. And the GUID's the GUID. Oops. Don't ask me why that isn't there, because I don't know. And that's it, actually, right? And so then we just need to update our hash table to record the fact that we added a new one, and then I think we're done. So that should now build a complete attribution table that says who is responsible for each portion of this thing. That's next in hash. And so now when I run this, we won't really see anything different, but if I didn't screw anything up, we are now building that hash table in the background. And so when I come in here and view this thing, we should now be able to add a new button here that's like, much like we can set debug on or off, we should be able to also set, excuse me, we should be able to also set a call sites on and off in that, just like we did show suppressed, right? So here we would say show call sites. And so in terms of show call sites, what I want to do is just, again, look for where we did show suppressed and previously... Set? Yeah. So just do this. Call sites and show call sites. Show call sites. Like so. And so now we have the ability, excuse me. Now we have the ability to turn call sites on and off, and all we need to do is add a mode in here that will display them as we kind of go down the list. So what I'm going to do is we're going to print this thing out, and then what we're going to do is if that call sites thing is true, so if we said show call sites, then now what I want to do is go through my hash table, excuse me, and for anything that's in this arena, I want to print out those call sites one by one. Now, I could use a chain to do that, but I don't care, so I'm not going to, because it's just not going to cost me enough time. And plus, this number, this is the top clock list. I'm in the wrong place. Sorry about that. I meant this one. So when I print this out, I then, after we do this, I'm going to go ahead and put it in here. Which you technically should probably be here. If we said to show call sites, I'm going to loop through, and remember this number, this is just the size of the hash table in terms of efficiency. The number of call sites is not that high, so this doesn't have to be that high. But I do have to loop over each of the slots every time if I want to find one of these, and that is a bit expensive, so I could use a chain if I didn't want to. I could just have a chain for each arena that threads through. I don't think it's worth it at the moment, but if it turned out to be, we could. So I'm going to do slot index equals 0, slot index less than, call site hash size. And also I might just undef call site hash size here so that no one has to worry about it. So with this call site hash size, in fact, I could have just made that a U32. I don't know why I didn't. But with the call site hash size, as I loop through there, I now can look at the call site hash. And, well, actually, I can just copy this exact routine here. This is all we're doing. We loop over each of the entries in that particular slot, and we print them out. So for each site, if it matches the arena that we're trying to print out at this time, right? We don't want to print ones that aren't. Then what we want to do is just display something that tells us what happened here. and, you know, something like that. Right? Okay. So we need something that will print out the information for this particular call site, which is not the same thing as we were doing before. But some of it's the same. We know that the call site here is going to get, its GUID printed out. We know that the site has a track for the amount that it allocated. So we know this piece of information, right? So the allocated, so site allocated count is how many of the things we were going to do. And similarly, we've got the site allocated sum. Could be the same thing as we were doing here, right? So that's the total amount divided by megabytes so that we can put that in there, right? This percentage we could also do, which is to say that we can say what, it's the same thing, right? We can just say whatever this allocated sum is, we can put out the percentage that it is of the total allocations. We could also make it be per arena if we wanted to, but yeah. So we don't have blocks in this case, so we really only have this one. We don't have them, because this is already out of, like, we don't know, we can't say that a particular call site caused a block to be created, because that's really just chance. It's like a whole bunch of other call sites might have used all the block, and you just wanted this little piece of memory. We can't say that it's like your fault, right? So I don't think we want anything more specific than just, here's how much memory the thing happened to use. Anything else would be a misleading statistic, and really what you should be doing if you're worried about that is looking at the graphical display, because that will actually tell you who's responsible for that kind of nonsense, right? So if I turn on call sites now, what we should be able to see, hopefully, is that when we look through here, we should see call sites and who is actually responsible for most of the memory. Now, what it looks like is happening, and I guess this explains the behavior that we were seeing, you can see that like almost no memory, even though there's tons of allocations being allocated by these streams here, nothing is actually getting, they're not using hardly any memory. So that's probably why we're not seeing it in here, because nothing's happening with it, right? It's like tiny little slivers. So that's great. It tells us what we wanted to know, and it helps us understand what's going on. I don't like how this isn't lined up, and so I'd like to push this back further by inserting, 1, 2, 3, 4, 5 spaces in there, just to get that more correct, right? And then in here, I want to do something like this, just to make sure you can see that it's like underneath it. Maybe that. And so here now we can see those call sites and really have a better understanding of who is responsible for each of the things that in the memory map, right? So here in my call site display now, it should be a little bit better. Yeah, it looks better. So you can see all the allocations listed here. You can see how much memory each of them is taking. And so when we turn on call sites, we can just immediately look and say, well, okay, so it's pretty much this allocation and this allocation that account for all of the memory. The rest of this stuff is just irrelevant anyway. These stream allocations here, the interesting thing about it is why they're not going away. And so I think the more interesting question to ask would be, do we have a leak in here somewhere where we were supposed to be freeing a stream when we, for example, loaded something up? I think the answer is no. My assumption is that this is the error streams that we record on import. Why there are so many of these unnecessary allocations, though, because presumably there aren't that many errors getting reported. We look in here, we don't see much happening there. So I'm wondering, why is that the case? And so I'm interested to know if maybe there's something going on there that shouldn't be going on. And I'd like to take a look at that and find out why. You can also see that there's an exactly matched pairing of these two here, 106 and 12, are happening what appears to be on the exact same code path. There's also a set in asset.cpp that's accounting for a lot of those. Let's go look and see what these are, just so we can have some idea of what the heck is happening, right? So I'm going to first start with the ones in the asset system proper, 735 in Handmade asset. And so we look in here and we see we've got a base name for the asset source file. So I guess all that's happening here is it's just pulling in when we were doing the import, right? When we check for that import, it's just remembering all of those names, right? And that's probably, there's probably two of those that should be back to back, right? 735 and 734. Yeah, so it's just storing these two pieces of information. That's good news because that's actually effectively debug information. It's information that doesn't actually need to happen when you're running the game. So we don't really have to care about that in two ways. A, we don't have to care about it because it won't happen at runtime, and B, it's not taking up much memory either. All right, so let's see where these stream ones are coming from. That's 106 and 12. The problem we're going to have there, I think, is just that when we're calling these outfs, we don't really know, on whose behalf they're happening. So this is not getting the information it needs to really know who was responsible, right? And so it's hard to say. What we could do is we could propagate that information forward. We could make outf arglist actually pass through that information. I don't know. And what's interesting is it looks like it sort of already is passing through that information. In which case, if I was to actually look at push copy, I could just start calling that with the actual debug name there. And that's kind of interesting. So let's suppose, just for sake of argument here, if we went into that stream system, and instead of using file name and line number for the chunks, instead we said something like, hey, there's a GUID there, that gets associated with each individual stream chunk. Then what I could do is I could leverage the debug system and say, well, let's make outf conform to that same procedure. That seems like a pretty good idea. I don't know. I mean, maybe it's dumb, maybe it's not. But if we went ahead and said, only put these in here if you're actually doing an internal build, because otherwise the GUIDs really shouldn't be there. And then I went and looked at the debug interface, and I just copy like that same sort of idea where we generate GUIDs for everybody who's doing that. Oh wait, sorry, it's the memory. I don't know why I said debug system. So in here, right, we've got the internal memory param and the internal memory pass. So I think what we can do is just kind of copy that idea. So in here where we've got our outf arglist and outf, we can just say, look, those are going to take one of these things, and we'll just piggyback on that memory system and its understanding of what's happening there. And then when we have the outf stuff, what we're going to do is actually use a debug name at the call site location. So here where we generate the debug name, and you know what, I'm not sure why there's a comma there, because really there shouldn't be, right? Oh, I know why. It's because debug name, we could have done it this way if debug name had just expanded to a comma, but oh well. So anyway, if I do handmade internal here, Then what I can do is just have two of these where we say, all right, in one case, we'll do an outf debug name there. In the other case, we just won't do anything, and we'll just call it regularly. Then we should be good to go for making these things work correctly in both cases, hopefully. Also, I think we need the little doodad there. Not really, though, because you're always actually going to pass something, but either way. So I think that's correct. And now if I go in and record inside here and make this be the internal memory param, and then here we do a internal memory pass, right? We should now have this stuff hooked up so that it flows through and tells us who is actually doing these allocations and why. Again, not sure that's the greatest idea, but, you know, I just thought it might be worth a shot. In here, I'm going to, oops, if handmade internal, otherwise nothing. So yeah, so that all seems good. And then in here, if we want to dump these out, then what we could do is say, well, anytime we're dumping the stream to the CRT like this, what we can do is just, if we know this, we print it. If we don't, we don't. So if we're in handmade internal mode, we know that we have this tracking information with it. So we can just say, show the GUID, which has the file name and line number in it, which is exactly what we wanted. If it doesn't, then we can't. No big deal. All right. When we do the error arg list here, that seems fine for out if arg list. We would need to generate a debug name here potentially. And it feels like that wants to get that passed as well, in a sense. But I don't know to what extent we really want to go down that road. So what I may do here is just say, I may just go ahead and do it this way. So we'll actually generate a debug name here for ourselves. Like so. Right in that case. Oops, that needed a comma there. Or should have. Yeah. And so now maybe we get a little bit more visibility into this. I don't know. Again, not sure that was really necessary or if it was a good idea, but we're going to find out. Cannot open. Oh, yeah, I agree with that. Let's try rebuilding that. And so this should just give us a little more detail about when and where those stream allocations are coming from. Molly Bean! Come on up. Come on up. There's a good girl. That's my good girl. That's a good girl. How you doing? How's it going? Did you just have dinner? Did you have, is it 6 o'clock? Yeah. Did you just have your dinner? She has a little automated feeder that goes off at regular intervals. I just feel like that's better for her because she, you know, there's no variability to it. She can rely on her meal times if I'm not there or something, you know. It's for her dry food. Her wet food still obviously has to be done by a human, but her dry food, isn't that right? Her dry food you can give herself. She can feed herself. All right. So let's see. Does that give us any more insight into whether or not those things are supposed to be happening, just in case there's an issue with them? Oh, okay. What are you doing, baby? What's going on? What's going on? I'm just finishing up programming. It's just a little bit longer. Actually, don't know how much longer it is. It's maybe 45 minutes longer, which is actually quite a bit longer. I'm sorry. We can play later if you want to. I don't know what you want to do. You can sit here if you want, although it's a little hard to type around you. You know we have a problem with this every day at work. That's a good bean. That's a good bean. Okay. Well, I don't know what's going on here with Molly. She's going to make her own decisions. She may just sit on the keyboard, in which case the stream is basically over. We can try to put her in the cat tree, and maybe she'll sit, maybe she won't. Who knows? Do you need a good brushing? I didn't brush you yesterday, did I? Did I brush you yesterday? I don't think I did. I'm sorry. We should brush you later. We'll brush you later, okay? Right after the stream, we'll give you good brushing. You'll be all nice and clean. So anyway, looking at the call sites here, just see if we got any more info. Okay. Molly wants to modify the mouse position as well. As is her prerogative. Okay. Those are my headphones. Can we step over the headphones? Can we step over the headphones a little bit? There we go. Okay. So I don't know if we got any information about the call sites here that'll help us figure things out. There might be, but there might not be. So taking a look in here at the stream allocations that used to be there, you can see now that some of them have gotten more detailed, right? So, for example, these two we know were previously allocations that are just made to track source asset files, of which we have many now, because there's just, even though the game isn't really have even probably a tenth of the art, will have, there's just a lot of source files, a lot of source PNGs for things like fonts, you know, that ups that number really quickly. And so if we look down now, we can see that there's 360 allocations still happening from stream 12, but now we've got some more information about what's happening. For example, in here, this is coming from import 1127. And so that gives us the opportunity to go there and just see, is that something that should have stuck around or isn't it, right? Let's see here, Handmade import 1127, right? And so it looks like these are error messages telling us that it found information in something that was supposed to be a blank tile. So that's just an error. We're getting errors on some blank tile stuff. There must be something is happening with our asset metadata. So the interesting thing about that is I think that may be an erroneous error message at this point, though, because the thing is that error message is probably wrong for font bitmaps because they don't have a type ID, if I'm not mistaken, because they're never referenced. Now maybe we should get, they have direct asset references in the font, right? So they don't get looked up by their type, and I think their type is just set to 0. Now that may be bad because it may be that that's sort of a bit of breakage in the system that we don't really want. But I do think that sort of indicates that this error message is not appropriate because it's erroring on something that's actually fine. So I might go ahead and do this. I could do this and comment it out, or I can go try to fix that now. And I'm not sure which one I want to do. I suppose just doing an asset rebuild is pretty trivial, and we could just add a type for it. Let's see what that would entail. Would it break anything else? Because I would like to still know this piece of information. In the future, when we sort of refine our import maybe a little bit, I think that's a good thing to have in there. So if I went to the file format and just said, hey, we've got the basic types here, where did those go? So inside here, you know, in fact, there's font glyph right there. I think we're just not using that anymore, but we could. And if we did, then presumably we wouldn't have that erroneous error. So like that would be when we actually do the import font, right? No. In here, when the tags for that font are being created, right? So we come through here, we're parsing these things, and we get these various glyphs. When we come through here and we set everything up, we look for the asset data and we set the code points all up in here, right? And so this process, every time we do this, when we load that bitmap, which is going to be this call here, update asset data from file. So if we're looking at this, we're passing it null tags and template tags. And I'm guessing that that's really the issue here. So when this thing gets updated, and it's going to look to see, right, it does this update asset metadata, right? And it passes those template tags. So the template tags here are just never set, right? So I guess what I would say is that seems like the issue, and maybe we should just fix it. Yeah. I don't know. I think that's what we need to do. So if we look through the template tags there, it looks like nobody else even uses them. Yeah, they don't. And so, you know, that's probably all we would really need to do is just say, well, the template tags, they have, this is the tag grid or whatever it is called, their import grid tags. Inside the first one of those, the type ID of this thing is going to want to be that font glyph, right? And so I think that's all we really need to do is make sure that that gets set everywhere. Looks like that's... I did that wrong. Sorry, it's just asset font glyph now. That was old news. So yeah, if I go ahead and go to the import code and just change that to be this, I think now all of those when they get imported would come in, hopefully, as font glyphs, and you wouldn't have that error happening. That's my assumption. And then that error would only occur on actual valid, things that are actually wrong. Okay. So if we go ahead and do our asset rebuild now, hopefully that would fix the problem. So inside Handmade, and that is in the data directory. So we've got the font, and the font is in the base game HHA. So I think if I just ask it to rebuild that, we should be good to go, probably. And then we can see whether or not we're still getting that erroring out where it's like looking, going like, hey man, these things I'm importing, they don't have any types associated with them. Do you care? Right? All right, and so that did the full asset rebuild of the game assets. So there'll be more call sites in here probably, right? Than there would have been before, because we would have saved some reporting about what actually got imported. But off we go. So let's now take a look and see, although actually, even just looking at it now, it does look like maybe that already improved things a little, but let's take a look. So now on a fresh run where things have actually been built, let's take a look at what we've got here. So we've got 122 allocations coming from asset 1020. Well, actually, let's just start with one thing. That error is not happening anymore, right? So that was exactly what I thought it was. But let's just double check the rest of these. So I'm not sure what this error is. It looks like we've got assets that are saying they come from the same place in the sprite sheet. Yeah? So that seems bad. I wonder if that means we're not setting our annotations right for grid X and grid Y. Although it's awfully suspicious, so I'm kind of wondering if this is because of a way that we're attributing names to things that causes all of the font glyphs themselves to be registered to the same file name. So I wonder if that is the problem. Let's take a look. So when we do parse font block, for each one of the glyphs, we're going to call update asset data from file, right? And we use this import file match as the match. So in theory, though, that seems like it should be okay to me. Because it's going to create an asset source file for that piece of information, which should be unique. Yeah, that seems fine. So I don't know why that would be having... So I guess what I'm going to do is say, I don't really know exactly where that's coming from. So what I'd like to do is dump this file and see what's actually going on there. So if I run hha edit, I'm going to use the minus dump call, and I'm going to dump basegame.hha to basegame.txt, and then I want to run tab view on it. So if I take a look in here and just see what I've got, I should be able to get the annotation for this thing. And if I look at these, so I guess a couple things. First of all, I'm not sure why this thinks there's no type, because I thought I tried to set the type of each of these to be a font glyph. Now, it could be that HHA edit just doesn't know how to do that, and I could look for that. I'm not sure where this actually gets printed out. That's in read HHA. I don't care about that. Where does this actually figure out where to print things? So this is where we print things. Category name from ID. Is where we take care of this. In category name from ID, we definitely have asset font glyph. So it doesn't look like I'm actually doing this properly, because if I was, we would have seen that value show up here, right? Because it should have found it in that run through, and it should have decrypted it here. Well, decrypted it. It should have cracked it here and shown me the name, but instead it didn't. What I will say though is I must be looking at the wrong thing, because that prints out none and this would print out unknown. So I'm still at a bit of a loss there. There's the assets. We come through here, we print out a %u, %d, category count, category data. So I guess this part here I can see what the issue is. We don't add any actual tags. We just say what the type was. And since we don't actually add any tags, this still wouldn't be able to find out what that thing was. All right. I can see why that's an issue. Do I want to actually add a tag for that? I'm not sure. I'm not sure. But the part that I was looking at more specifically right now is the fact that all of these do have a separate source file name for them, right? So as I'm looping through here, you can see that they actually are totally distinct. So what I don't know is why we're getting this error message that says that there's things that are overlapping, because I don't actually see anything that's overlapping, unless I'm just missing it because I'm scrolling by too quickly. But honestly, it doesn't really look like it, right? So that would be an example of it. So it looks like these, because they're audio, they're chunked streaming audio. So the chunked streaming audio does have sort of a, it has two things that say that they're coming from the same place. And so the problem with that is it's really just totally okay that that's the case. You just want to take the earlier asset index in the case of streaming audio. So I think really all I have to do is just always make sure I take the lesser of the two. I mean, that should be okay. So in this case, where we're going to look at it here, what we want to do is say, if it's equal to 0, well, then we assign it. If it's not, then we want to actually check to make sure that we actually want to report this. In the case where it's an audio asset, that's okay. So in other words, if this conflicted asset what's the actual... I want to know if it's a sound. So an HHA asset sound. So if this thing is a sound, then I don't want to print out that error message. Instead, what I want to do is assign this if it's less. right? So I just want to say if grid asset index is greater than global asset index, then, you know, assign it, right? Although since global asset index is always ascending, that probably isn't even necessary, but that's basically what we want to do. So we want to take the lowest value that we can get, and then we would know to replace the run if we had to actually replace it, right? So I'm interested to know, does that help us with our problem here? So looking at the memory readout here, it looks to me like 1029. So no, it didn't. So it looks like that, unfortunately, is not helpful. So we're still getting a bunch of these errors, and I just don't know on whose behalf we're getting them. We don't currently have a way to look at all errors in all source files, which we probably should have, because we would be able to see that if we did. We only have the main error stream here, and we don't have the per source file error stream, which would be nice. Maybe this should actually go to that error stream, but it's hard to say. So I'm going to do the poor man's version of this just for expedience at the moment, but it's probably something that we should take care of in a more definitive way later. If I go set a breakpoint where that happens, we can look at which assets are causing the issue and maybe get a better sense of why. So if I look at source file name, oops, of course we can't actually because it's all been optimized out. So here's the actual source file in question. What? So this is a case of somebody not actually specifying which source file they came from, looks like, which is surely an import bug, right? That means that somebody is not setting their actual annotation to have what the source file actually was. Let's take a look at what that asset looks like, just so we can have a better idea. So looking here, we can see a couple things. So it's a type 2. I don't know if I can. That's a sound. So it was actually a sound. We actually need to look at the HHA type here. That's what we're looking at. Let's try that one more time. There we go. Okay. So we shouldn't be looking at sounds now, hopefully, right? So the type is type 3, and that type is a font. So the font is saying it came from a base name, a source file name of base game, and that doesn't seem useful. But I guess now that I think about it, it's hard to say where else it would come from. So that's probably correct, actually. However, what else is occupying that slot? Because I guess there could be one other asset in there. Yeah. Yeah, I'm not sure what else we could do, because if these things are chained on the actual HHA file, then you kind of have a nasty situation where what else are you going to do? If you have like multiple fonts, they're all going to be using base game as their asset source file. That doesn't really work. It's just a bad problem that we have here. So fortunately, we're just down to the two, it looks like, on there now. So it was the sounds that were causing most of the problem, it looks like. But we still do have two of those, and that's probably something we want to fix eventually. Looking again at the call sites, let me speed this back up again. But looking again at the call sites here, let me just size this out. Now we only have 3 calls there, which seems more plausible. So that's better. In fact, looking now at the allocations, they look correct, right? So that's looking pretty good. So we've cleaned up a bunch of that stuff. Yeah, and all that stuff seems fine. In general now too, one of the things that these call sites do that's nice is looking at the overall, like if we just saw that, it's really important for us to be able to name our arenas because we have no idea who the heck is responsible for these, right? But when you turn this on, now you can see right away like some detail about what the allocations were, and it would allow us to not really have to care if those things were named or not, right? So we can go look and see, like, okay, so who's responsible for this one allocation in handmade memory.h 388, right? Like, what's going on there? And you can see that that's a bootstrap, and the bootstrap allocation, I guess in this case, is not passing through who's doing it. So I would say we probably do want to pass through who's doing it for bootstrapping. It seems like something you would want. And I don't know if there was a reason why we didn't do that. But for now, I think I would like to. So in order to do that in the bootstrap stuff, what we would want to do here is say the bootstraps struct piece here is going to probably get pulled up, right? And so that'll go in here and do this and that. In this case, it will do exactly what it was doing, but in this case, it will do a debug name here. And it will be bootstrap push size. So I think that would allow us to do the same thing we're doing everywhere else. So this would be internal memory param, and this would be internal memory pass, and this would actually be a underscored one. And so now in theory we can track that allocation upward and see what's going on. So inside here you can see us calling this bootstrap push size directly. I couldn't really say why, though. Okay. So if we do want to do that where we're creating the frame arena here, when we call bootstrap push size, it would seem that we would have to pass the debug name here. And that's a pretty weird way of doing things, but I guess we're doing it because we just want to use offset 0, which, hey, works. But I don't know that that's maybe the smartest thing to do. If we're doing it that way, though, yeah, we want to be able to pass a debug name as the first thing. I, again, have to ask why debug name itself doesn't just evaluate to something smarter. If, for example, debug name always evaluated to something with a comma after it, then we wouldn't have to make multiple versions of all these things, which seems like it would be a lot nicer than what we have going right now. And so, you know, I'm just looking at this, and you know, you've always got it so that it's doing this, right? Pretty much everywhere you have debug name, it's just always like comma, 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 right? And so it feels like if we just made it evaluate to a comma in the first place, then we could have put this at the front of everything, and you wouldn't have had to actually worry about defining it differently in debug mode. I guess here's a case where the comma would have been unwelcome. So I don't know. I'm a little bit torn there, but oh well. So I'll just go ahead and keep going the sort of not particularly fantastic route that we have been going. And we'll just put it in here. So that'll, oops, that'll correctly track that push by giving it an actual name as it wanted. And now if I run, hopefully in theory, that will eliminate one of our mystery allocations there and actually attribute it to somebody instead of nobody. So now we can see it actually getting attributed properly to Handmade CPP 185. And hey, of course, we now know that because we know that it was here. But, you know, it's good to see it. So that gets attributed to here. And similarly, this one should now inside the frame temporary. That should get attributed to 187, and it is. So those two are now nicely attributed. We could also label this arena pretty easily, I think. When these are created here inside the game state, I assume we could, if we wanted to, label those it's just the game state's total arena. And somehow that one wasn't getting labeled. So like if I go to game state, this total arena like didn't get labeled, I guess. And hey, I guess that's actually true. So for some reason, yeah, I don't know. For some reason, we just weren't labeling that one, and I don't know why. And so now we have it labeled, as you can see. So this one is the only one that's a little bit squinky now, and we should probably go take a look at that. It looks like it's, you know, it's part of the import system, so it's probably just the error output or whatever that was going on there. We might as well label that. And again, the call sites really lets us jump right to what's going on. So 2230 on the Handmade import. And so in here, we want to go ahead and have this error stream. On-demand memory stream is who's picking that up. And so probably we just want to label that. If I go in there and look at how on-demand memory stream's working, you can see that we've got that stream memory here. So what we probably want to do is right after that just say debug arena name, grab that particular error stream, and say that that is the synchronize asset file changes. Um, so basically, I mean, that's what it is, right? It's the standard out for the change synchronization. So I think that's what we need there. Let's find out. There we go. So the name won't change here because that path will not get called. It only happens at import time, so we're never going to hit that again. But if I run it now from the start again, then we should see that that name get picked up, hopefully. Although, as I say that, that's obviously not true, because it should have been there, and it isn't. Right? So I don't know what to make of that. Is it... Oh. Wait. Error stream... How did that compile? All right. Let's try that one more time. I don't know what was going on there. All right. Try that one more time. So hopefully this will name it now. And it doesn't. Well, so much for that. So I'm not sure what's going on. These are the allocations here. There's 2231, right, was that site we just looked at. And I guess the problem is probably that it hasn't had any blocks yet, and you can't label one without blocks. So, all right, I guess that's true. Oh well. So maybe we just need to do it that way, and then we're okay. Not the cleanest solution, but you know, we don't have a way of, because arenas can get moved around where you're tracking them from, and we didn't want to make it so that people had to like be cognizant of that. So that was just yeah. So now we've got it. So I think now we're properly tracking everyone's memory. We know the call sites, so we can see for every arena who is messing with it and why, and that's really nice. So I think all of that is pleasant and good. I would say that now we can move on to the last order of business in what time we have remaining, and just take a look at making this display make more sense. Again, so that it's not, so that it properly reflects the sizes of the things that it's showing. And so what I want to do there is just draw memory intervals or whatever, or arena intervals. All I really want to do here is say, all right, when we start creating these blocks, I need to start thinking of them less in terms of subdividing a block and more in terms of actually like rasterizing out for however long you're going a certain amount of space in this memory map that where everything should be equivalently sized, right? And so what I'd like to do there is have some way of actually mapping into this block directly, so that rather than thinking of it as block recs you subdivide, you actually just use your like absolute memory location to create the lookup into the block, and then you have a party, right? I think that's the saucier way to go here. So in order to do that, what I want to create is some sort of a notion of how to draw some range, and I'm going to need that to work as a function call that can do it sort of based on the total profile rect size. So you pass me one of these profile rect sizes or something like this, and then we say, look, here's the total, here's like your actual address in there. So I'm not sure exactly how I want to do that. But let's say that we do this as let's say that we do this as something like this. And then we're going to go ahead and in fact, maybe like that. So you pass us a range, and then we're going to fill the range. And so we need to have the render group in here and the UI transform, like that stuff. So we're going to have to take a little bit of state, and that's fine. So in here, what we do is, you know, we're doing something like this. And we're going to fill Rex, and we can obviously get the render group out of here as well, right? So we're going to get the render group, the UI transform. We need to know the block color. But other than that, I think we're all good. So in here, I would just say, pass me the block color that you want used. And I think that's probably all we need in there. And so then what we're going to do is we're going to say we have a way of mapping addresses to page, you know, we have a way of mapping addresses into this block. And I might want to do this in U64s. Let's do it. So you pass me your two ranges, and what I need to do here is I need to effectively fill the number of rows that you're going to occupy, and I need to fill however much of each row you occupy, right? When we do the push rect outline, really eventually what I should do is keep one side of that solid or not, depending on whether or not you actually wrap around to the next row. But we'll cross that bridge when we come to it. So we need to do one of these for every row that you that it encounters. So we need something here like a row index that we're going to step along, right? We need this sort of thing. And then for each of these, we need to know like what section of the row you actually take up. I'm guessing that I won't have time to quite do this today, just based on where we are time-wise. Yeah. So I might just leave it here, and then tomorrow what we'll do is we'll go through this stuff exactly. So when we're going to draw the arena intervals, I'll go ahead and make that call out to this, and we'll do the memory mapping into the range, so that each of these will just tell it exactly where it is in the total size of the memory, and then that will translate into the correct set of like rectangle fills for each region. And then that way we can also introduce a scaling factor, so that if we want to be able to zoom in on pieces of memory, we can, which I think we'll probably want to do eventually as well. So yeah, let's stop there because we did a ton of stuff today, and let's move to the Q&A here. you code C++ for your day job? Yes. All these without comma macros is complete nonsense. Is there any better way to deal with it? Yeah, it is complete nonsense. And again, like, C and C++ just aren't good languages for actually building complex programs. There are very simple language features that would have made all of that stuff unnecessary, and they just never added them. And so typically what C++ in particular does, because C was a fairly minimal language, C++ typically what it does is it says, well, okay, so let's suppose you wanted to do that thing we were just doing. They have all these sort of like halfway implemented language features that don't really work, but that would sort of maybe help you address that problem. And if you end up trying to use them, your code's even worse than what we just ended up with, right? And so it's always very frustrating. If we wanted to do something better with our actual with and without memory macro stuff, I do think we can do better than that, though, just with the preprocessor. And the reason I say that is because if we just introduced another debug name thing here, like let's say we just bit the bullet and say, well, we've got inside the Handmade debug interface stuff, we've got this one way that we create debug names, right? Here it is. Well, maybe we say, all right, so there's another one, which is like debug memory param or something, right? Like this. And what that does is it just says like, well, normally when you say this thing, then I expand it to this, right? And I put the comma on for you. You know what I'm saying? And in the other case, I don't do that. So if you instead are not in the internal build, then it just goes away, right? It just disappears. And so if we wanted to do that, then I think what we could do is simplify this quite considerably, right? We drop that up there and drop that in here. And now I think you could just get rid of this entire else set, I think, right? Because now what I believe we could do is just instead of using debug name everywhere here, we would just say debug memory param as the first thing, right? And then we don't have to have the two versions ever. Although I guess I should, for posterity, in case we ever do want to re-enable it, we got rid of it because of Clang. I'm going to keep... Maybe I'll call that debug memory name. So if I just do this and then remove these, I think that's probably sufficient. And so that would be one way to make it at least somewhat cleaner. We don't really need these pounds because these all take arguments, so there's no chance that there are 0 arguments there. So I think that should probably be fine as it is. So I think that's pretty much everything. And then you don't need the multiple version nonsense anymore. I think that would just take care of it, right? And so that's pretty compelling by comparison. It looks like my push and null terminate is wrong there. Where is push and null terminate? Push and null terminate. Yeah. So that's one way. And that seems better. Like, I probably should have done that, right? That seems like an improvement to me. Again, it's hard to do a good job in C, C++ for that sort of thing. All of your options are substandard. Like, none of them are great. But C++ is not a great language. So you can't expect to get great code out of a non-great language. It's kind of self-definingly not going to happen. But that's, better than what we had, and keeps it a little bit more, concise. You don't have the two versions of everything. And it would also allow us, in the other places where we did that, to remove them as well. So, if I go looking for the places where we put those in here, so like right here, for example, we should be able to also say, well, this doesn't have to occur because we can use the same trick right here. So anyone who wants to participate in that scheme can just do it, and it's not an issue, right? Same thing here. I don't know that we had any more of these. Those may have been all of them. Probably should have just looked for debug name in there, but it's okay. Yeah. I can also test, and just because we made that change there, let's see if we broke anything when Handmade internal is off, because there might be some places now where that's busted, and we want to make sure we fix that. So it looks like bootstrap push struct is still broken, so let's just fix that real quick. Yeah, so that one's missing this. And what else you got? So there we go. So now the non-internal version is working, and off we go there. But if we want to turn it back on, now we can. I'm a web developer by trade, and my day-to-day code seems to abstract way more logic than you do in your engine. Could you explain why that is? I'm not sure what exactly you mean by the question. Can you be any more specific? I mean, one of the things, I guess, is obviously that this stream is about doing low-level code, so obviously we're not going to abstract things any more than we have to, but that may not really be what you're asking, so if you could explain that question a little bit more, I could try to address it more properly. What would you do differently if you had to work with other developers on this project? I wouldn't really do anything differently in most instances, but when I'm working with other developers, typically we come to some sort of an understanding about like where we're going to put like fault lines in the code base, really. And what I would do is I'd spend more time periodically creating interface boundaries that were like clean separations that other people could look at and go, oh, okay, here's the stuff that like Casey wants me to call to use like the asset system or whatever, so that they don't have to wonder, right? I don't spend a lot of time doing that with what I'm doing now because I know, so it's just a waste of time. But if I know that other people have to be calling the code, then I treat it more like a public API that I might be pushing out to the world, right? And so I'm going to stop and make those boundaries clear and have a clear H file that's like, hey, everyone look at this. This is the part that you want to call, so that you don't have to know anything about what I'm doing. You can just call the part that I told you was reliable and do it, right? And so, when I used to ship licensable SDKs, for example, that I would just apply that mentality to the to the part that I wanted to wall off at any given time, right? So like when I am making a SDK for someone else to use, there's the internal part that I'm working on, and I don't care if anyone else knows how that works. But then there's the part that I want them to call, and I want that to be like obvious, right? I want to be like, here's the, begin, execute, end stuff. Here's what you can call. Here's maybe some comments that say, here's an example code or whatever. And so I would, take the time to push that periodically when I wanted people to be using a new feature. Does that make sense? Or a new thing that I added. But in terms of the internals, I wouldn't really do anything particularly different. I might put more error checking code in as well, because if I put error checking code in places that I know I probably will never make an error, I'm wasting my time. But if I know that other people are calling it, and I don't know what kinds of errors they often have, or what kinds of errors they might make because they don't know how I normally do things in my code, then I might put some guards in to look for things they're doing wrong. Do you see what I'm saying? And that's to help them save debugging time so that they don't get something wrong and then waste their time trying to debug what happened. Does that make sense? So those are some things that you want to do differently when you know that the person using the code in many cases isn't you. But when you're making code for yourself, you don't want to waste your time doing those things necessarily, right? Yes, exactly. This is better, but it can't do just one name. And that's actually why I made it debug memory name and didn't change the one that's debug name, because debug memory name, we know we always take something, right? And so it's just and again, it's just crappy. It's just because, it's crappy. But you do the best you can with C++, right? I'm wondering what language feature would make what you have done with memory tracking easier. Well, it's obvious, right? You should just be able inside a function. I mean, right? Something like this. Because essentially what happens is you have a call graph at compile time where the compiler knows everybody who's called, right? And for 99% of all functions, you're not calling through a pointer. So it's actually easy for the compiler to just push that information for anyone who actually needs it in the call graph. So languages could easily just add something that automatically adds a pass parameter if the person who's getting called wants to know who the caller was, right? And that creates literally this exact code, but you didn't have to type it in. If someone were looking to get into game programming today, would you recommend starting with using an engine like Unity, or would you recommend doing this lower level programming? I think I would say it depends on what your goal is. If you're trying to be like a game designer, I would say you want to use something like Unity or Unreal. And the reason is because those tools are what are the kind of thing you will be expected to use. So when you go to get a job as a game designer, they will expect you to be working with something like that. It may not be one of those because they may have their own in-house engine, but it's going to be something like a scriptable, like Unity style thing, right? If on the other hand, what you're trying to do is get a job as an engine programmer, then what I would say is, yeah, I don't know how useful starting with Unity or Unreal would be. it might be bad because they're very large and very complex. And so if you're trying to learn engine programming, I mean, there's no reason you couldn't learn engine programming by downloading the source code to the Unreal Engine, which I believe is public, and hacking on it, right? I mean, you can do that, but you might be overwhelmed. Whereas starting with some simple Pong game you make low level, like what we do on Handmade Hero, there you might be able to learn a lot more because it's so much easier to grapple with that than this huge multi-million line source tree, right? And so I think when you're starting to get into game programming, there isn't a right answer. It's like, what am I trying to achieve and what can I grapple with? Like, you know, what do I get the most mental traction on? And that's probably what you should be doing, because you will learn if you do it a lot. And so the question is, what is your brain willing to do a lot of? And you should do that thing, right? And starting with something like the Unreal Engine might be too much, right? And so you might want to scope it down. And that doesn't mean you have to do like what we're doing. You could do other things. Start with the Quake source code that you download or something. I don't know, but I'm just saying, like, try to find something that you can like grapple with and go with that. Don't be afraid to try a few things to see if any of them stick. And if none of them stick, maybe you shouldn't be a programmer, right? Like, you don't have to be a programmer. There's lots of jobs that people do in the game industry: production, art, sound design, regular design, management, marketing, community management. Programming is just one of them. So don't be afraid to experiment and see what it is that you actually like and are good at, and go from there, right? Off topic, question about render group. What is the purpose of this entity object API in a few words nowadays? Is it essentially a command buffer for a specific FBO, for a specific GL state? Not really. A render group nowadays, and let me just bring it up here so we can talk about it. So really what's happening here is this is just saying that we know we have some actual stuff that the renderer needs to do, like actual work, that we rely on the platform's implementation of something, OpenGL, Direct3D, whatever. We have some mini driver that sits on top of that is capable of actually doing the rendering work, like drawing quads and depth sorting and all that crap, right? But in order for the game to actually stream out the actual information that mini driver needs, right? There's just a lot going on. There's all sorts of stuff like, okay, where am I in the output stream to put like vertex data out? What's the actual transform that I expect to be using here? Like, just a bunch of bookkeeping. And so what the render group does is it just packages that up into one place, so that all of the people who actually use rendering and throw stuff down to be rendered don't have to track it all separately. So that's all it is it's a bookkeeping aid, so that people who want to push stuff to the renderer don't have to remember every last, was lighting on or off, and where was the lighting going, and how do I get to the assets to like figure out which texture I'm using. It just puts that together so that you don't have to pass tons of things down the pipeline or find that you're somewhere trying to render something and you don't have something you need. So it's a bookkeeping simplification struct. And you'll see that happen a lot in complex systems because there's so many moving pieces. You don't want to pass them all. You just want one pointer to something that has all of the stuff you might need in it, and you just grab the one you want, right? Why are games unable to saturate storage bandwidth when loading? With modern SSDs, it seems like load should never take longer than 2 to 3 seconds. You're absolutely right, and the reason is usually just bad asset processing. right? So typically what happens is like they load things, tons of disparate tiny little chunks, and then they have to like wire them all up. And they're like matching strings like crazy and like remap, unbundling stuff and just crazy bad code that's doing a ton of work. And so rather than just issuing a giant set of IO ops that it can just like saturate the SSD and pull it out as fast as possible, instead it's just this nonsense dance of like, grabbing little tiny pieces that are not really fully processed and checking whose name matches to what, and oh, that thing referenced this other thing. Where is that thing? I don't know. Let me look it up in a table. Oh, it's over there. Issue an IO call to that. So it's like a lot of these little serial bubbles. Load this tiny thing. What does it need? Oh, load that thing that it needs. Oh, that thing needs something. Okay, load that, right? And so you end up in this case where you're constantly waiting for the full latency. Whereas if you just knew everything you needed for the next level and issued it all at once, it could just all come back, right? And so it's those latency bubbles of I asked for something, then I need to look at it to find out what to ask for next. That process is doing these big round trips through the whole pipeline. And so even though the SSD can sustain this really high bandwidth back, if you're just trickle asking for it and then it has to wait all the time, it's constantly like stalling out, right? It's like, oh, wait, okay, what did I, oh, this, oh, okay, oh, this, oh, okay, right? And so it's just sloppy programming, right? You've mentioned that with the engine you're writing for 975, you're spending a lot more time documenting your process and decisions when tackling a problem. Do you have any tips or examples of what you find useful to keep track of? Yes, I can tell you exactly how I do it. So specifically what I do is every time I am not sure what the answer is to something I'm doing, that gets an entry in the log. So if I'm like, well, I could do this thing by doing it X, but I could do it by Y, and I'm not sure which one to do. Or maybe like I could do X, but maybe X isn't quite right, and I'm not sure what is right, that gets an entry. And I describe why I'm confused, right? So I'm like, well, here are the pros to X, and here are the pros to Y. And then I say, at the bottom, I'm like, I'm going to go with X for now, but I'm not sure. And then later, if I ever find out the actual answer, like I implement it and I'm like, oh, it turned out X is really good, or wow, X was terrible, don't do that, let's switch to Y. Then I go back into that comment block and I say, I put a little thing that says resolved. I'm like, resolved, you don't do X because this happens. So do Y because it doesn't, right? That's what I keep track of. So any decision that wasn't obvious, that's what I try to keep track of. Is there a good rule of thumb when it comes to guarding against errors in your code? Is there such a thing as too much handling? I can imagine having many if statements, check conditionals could cause a performance hit. So a couple things. The first thing I'll say is on the performance hit side of things. It doesn't really cause a huge performance hit on an x64 processor anyway to have ifs for error handling. And that's because usually the if to check the error condition doesn't require much work. And branches that are always taken in one way are usually fairly cheap, right? So meaning if you have a branch which is like, if everything's okay, do this stuff. Those are pretty cheap branches. In fact, they're almost free branches if you didn't have to do any work to compute the thing that you're branching on. And so I would say on x64, you can probably afford to have a fair bit of that code. I mean, it depends on the context. So certain cases, maybe not, but in a lot of cases, it's okay. But what I would say is it's more about you wasting your own time. So don't waste your time adding error checking in places you don't think you need it. And so that gets to the first part of your question, which is what's the rule of thumb? Where do you need it? And what I would say there is that if you don't know what kind of bugs you're likely to make, because you just aren't sure, you haven't been keeping track of that, right? then what you want to do is you want to start by saying, every time, I'm going to set aside this month. Every time this month I hit a bug in my code that I have to debug, I'm going to write down what it was. What kind of bug was it, right? And at the end of the month, you will know the kind of errors you tend to have, right? And that will give you some information about, what you should be guarding against more often. The other thing you can also do that helps is when you have bugs, when you debug the bug, ask yourself, how long did that take? If the answer was a minute, probably no need to do anything about it. If the answer was 5, 10, a half hour, then ask yourself, what is the check that would have prevented this bug? Go and add that check and remember it, right? That's usually a pretty good rule of thumb too. So does it mean that you have augmented this caller information in your metaprogramming scheme so you can always query who called you? I hope that John integrated these features in JI already. I don't know if John has them in JI already or not, but it's not metaprogramming really, because all you're saying is, I want to be able to have access to the call graph in a way that generates something. And that's just regular programming, really. So for more specifics on where you log, do you have a file for each function? No, I just have one giant file called like devlog or notes or something. Render group, thanks for answering. Sounds like an abstraction of GL API plus the notion of render path. No, still not really. And the reason I say that is because a render group can actually just get modified on the fly. So like as you're coming down and doing stuff, you can change like the transform as you go. So I really would encourage you to think of it more as bookkeeping. It's transient. So render groups themselves don't get handed to anybody. They go away after they're used. So they're really just bookkeeping. They're there to track the state as it goes. So it's more like a abstraction of all the state necessary to issue render calls, and it updates as it goes as you change that state, but it doesn't record it anywhere. So the actual recording is done in other things, right? That's what I would say. What are your thoughts on visual programming languages? Do you imagine good use cases for them? And if so, in what context do you think they work? My understanding is that it's challenging to make a good visual language and that usually the special purpose ones work better than attempts at general use ones. First of all, I would agree with the back half of that, the part that you said my understanding is. I would say that like the kinds of visual languages that I've seen which tend to look a lot like wiring diagrams, those are pretty limited in their utility. Like when I see people trying to take those and program really complex stuff in them, like when people use Blueprint to make complex stuff, I'm like, this is bad, right? It's way too complicated, very hard to read. And so I think that's kind of going off the rails there. But when you take a simpler example of something that you do in Blueprint, or like more to the point, a shading diagram in like Maya or something, if you just have a few things like, oh, here was the image and I applied this modifier to it and I can see that it got, it increased the contrast or whatever, and then I piped it to this text, this mesh, and there it is, right? You can kind of see that being, I'm like, okay, that's not bad. That's probably better than if I had to type in some code for that and didn't really know, especially if I'm not a programmer really, and I'm not used to thinking of things linguistically like that. It seems like a pretty clear win. So I'd agree with the back half of that. As to what my thoughts are on visual programming languages in general, I would say that I think that the idea of making languages that have visual components to them, as opposed to just a bunch of text on a page, is clearly good, because a lot of the things we program have a geometric component to them, and the fact that we can't see any of it doesn't help. But I would say that the idea that visual programming means wiring diagram seems misguided. There are people who've done experiments with visual programming that is not about wiring diagrams. Those look more promising to me, and so I would say that that seems like a more fruitful avenue for future progress than wiring diagram, which to me never really made sense as a way to do anything more than just simple image manipulation stuff, which is where those wiring diagrams seem to work okay, right? Question is, to touch on the over error checking, what about the case where you're making an API that is to be accessed by other developers? Right now I'm making a library for the Twitch API that will be constantly interfaced by users, but I feel like I'm holding their hand too much with errors instead of assuming that they have an idea what they're doing, to the point where a significant amount of the library is just error checking. Well, I guess what I would say is, obviously with anything including that, there's always still a balance to it. So I would say that you don't necessarily want to go overboard, but it's worth remembering that when someone else is using your code, they are coming into it completely blind, right? I mean, they have no idea what you did in there, and they are very much just feeling around to try and figure out what's going on, right? And so you do have to err on the side of being more pedantic and descriptive and sort of rigorous with your sort of error reporting, if nothing else, because they just aren't going to know what they did wrong a lot of times. Like, they're going to do something and it's just not going to work. And the reason, and it would be trivial for you to understand why it doesn't work because you know the internals. They don't. And so they're just going to be like, I don't know why that didn't work. So the crucial thing that you need to provide them is the way for them to gain the understanding of why it didn't work. An error log is very important in APIs like that. So they can just see, like, okay, this didn't work. Turn on logging. What happened? Oh, that call failed because I passed it a null pointer. I didn't realize that thing could return a null pointer, whatever. Or it failed and didn't produce an ID because the server was down, and I didn't know the server was down, so I thought it was okay, right? Blah, blah, blah. And so having the ability to look through an error log is pretty important for people who are trying to learn how to use an interface. And you do have to err more on the side of being more descriptive, putting more stuff in there, than if it's just for you, because you know the internals and you know what's possible and not. And so you just have to respect that difference of knowledge there. I think I'm running out of voice left to answer questions. Going back to a question near the beginning about abstract logic, I think the heart of the questions is due to a discussion about what is clean code. Some higher level languages seem to make things look good, but clean code is, at least to me, isn't very well defined. Maybe that they were looking for why does this look complex versus something that's a few lines of code but contained in a bunch of little files. My thoughts are due to performance fine-tuning and knowing exactly what's going on rather than guessing. I do that a lot using Python. Well, I guess there's a mixture of things. So first of all, the phrase clean code is, if someone uses the phrase clean code in a specific way, that usually concerns me. Sometimes we use it in an offhand, and using it offhand, it's not always bad. Like sometimes I will talk about something being not clean And what I mean by that is I know there's crap in there that I haven't finished yet, or that I stuck something in it that's kind of lousy, and I want to go, fix it later. And so in the sense that there's, clean code, to me what that usually means is I've finished it to the degree that I wanted it finished. And if I haven't done that, then it's probably pretty dirty in there, right? Like I haven't really had a chance to quite polish it up. And so I do think that that is a reasonable use of clean code. Saying the word clean code and referring to something like does things have classes with private sections or something, that I think is just absurd and silly. Those are people whose opinions I don't respect and hate working with, right? And so what I would say is you have to be careful about what you mean with various things, and what they mean in a lot of these different contexts, right? But going back to sort of the meat of the question, which is whether things take too many lines to implement, kind of seems like what we're talking about there. Then what I would say is, yeah, there's a lot of trade-offs kind of all mixed together, and you kind of have to pick what you're going to accept, right? Trade-off wise. And so you've got three things you can kind of pick from, and you really only get to have one of them. You can have code that actually works well on the CPU and is good, like it runs well, right? And if you want that, you pretty much have to use C or another fairly low-level language. It's very hard to get that, forget Python, PHP, it's not even close to being acceptable when it runs, right? And so, if what you care about is the actual quality of the executed code, there are very few things you can choose from. And they're all pretty verbose languages, right? It's hard to find languages that are good at making things concise, but which still generate highly optimal code. It's very hard to find that. And that's just a limitation so far in our ability to produce quality languages for that purpose. Okay. So that's like one issue. Another issue is if you want things to be concise, you can pick languages that maybe are good at having expressive power in terms of the technical output you are looking for, but where you don't care how poorly you get the result, right? So for example, you might find that in a language like ML, for example, you can produce some very nice things for certain types of problems that allow you to, in a very small amount of code, state something you want to have happen and get the correct answer, even though the code is not particularly good that comes out of it, right? And so those are two distinct courses you can pick there, right? And once in a while, if you're really lucky, you can find a language that can actually do both, but it's very rare. For most problems, you can't, right? So for most problems, you have to pick one of those two. And then there's a third thing, which is like prefab code, right? And so for example, when you talk about something like Python, that has nothing to do with the code. The only reason Python's useful at all is because there's so many libraries. The reason it looks like something in Python is concise is because you're calling a bunch of prefab code that somebody else made, right? You don't have to implement HTTPS yourself because there's a library there to do that for you. You don't have to implement SHA1 because there's a library for you, right? And so that is a separate concern altogether. It's whether or not you have any particular access to libraries that do the things that you need. That's a separate concern, and actually in many ways re-implicates the previous two things I said. Sometimes those libraries, you might find a really well-written library, and then it doesn't matter that you used it. You still get really high quality results because the library was written specifically to do the thing you want to do and was well written. Other times you may be like, well, I just care that this can do it at all, and the fact that this library can do it is good enough for me, even though it's slow and piggy and lame, right? And so I think you have a pretty wide set of concerns there that you have to manage. The reason that on Handmade Hero we write everything ourselves and we write it low level is because there's already plenty of material out there how to do it the other way, right? Grabbing someone else's library and just calling it is not something I really need to teach people to do. You should be able to find, right, plenty of people talking about that. And I think it's important that people learn this because my daily experience with other people's software is that it's terrible. Every single thing I use on the web is horrible, super slow, and absolutely like so far below the level of acceptable quality that I just completely rage out at it, right? And what's weird about that is, like, you know, I did the code for our website, and when I tried to use other people's stuff for this, it was so horrible that I just ended up writing my own in C, and it was way better, right? So again, like, that quality bar is like a real issue right now, and I think a lot of people are lying to themselves about the quality of the things that they're putting out by not writing things from scratch. And so it's a little bit less, to me, it's not so much that I think in the grand scheme of things, we will always have to write things at low level. I actually hope that's not true. But right now, people are using a lot of high-level things, either libraries or languages, that are actually just terrible, and they don't seem to care that the products they're producing are absolutely terrible to use. They're buggy, they're slow, they're unpredictable, they're not very maintainable, they have erroneous, weird transient errors a lot of the time. And I hope at least that some people who watch the series get a taste for implementing things themselves, because I'm just hoping that more people will take quality more seriously, which is really just, and you have to start here, right? You have to start just knowing how to do this basic stuff. And so this is just like a training ground for knowing how to implement things from scratch. And once you know how to implement things from scratch, then when you go to look at another problem, you can say, oh, I don't have to use this ridiculous, super piggy thing that takes 1.5 seconds to add someone's name to a mailing list on this website. I can write one myself that takes 10 milliseconds, including the ping time, and it's like 10 times better, right? And so this is just a way to say, hey, it's not that hard to implement things yourself. Here's how it looks. Yes, it takes longer to write something that's good and from scratch, but it's also way better, right? And so I guess that's what I would say. Have I tried Odin? No, I have not. What you're saying is really good, but opposite to what devs are being told in schools. Yeah, but I mean, that's true of most things that occur in schools. I mean, one of the things that's true about schools is those are not people who do production code for a living, right? So typically what someone gets taught in school is either completely uninformed by reality, which is often the case, and not just in programming, or it's old. right? It's old knowledge that, if it was ever true, is not true anymore, right? And so, it's a problem. But that's true of most things you learn in schools, right? Most things that happen at a university are not particularly well grounded in practicality, right? And to some degree, I think that's a bit of a reason why they're not particularly great for training people to actually do stuff. I mean, that wasn't really ever supposed to be the point of a university in the first place. Like, universities were supposed to be places people went to sort of abstractly study things, not where you went to be trained to do something. That's what a guild is, right? You didn't go to university to learn to be a blacksmith. You went to university to just study about the nature of metals or something, right? And so nowadays we've kind of got it mixed up. You go to university, learn about programming, but the people there aren't production programmers. The people who are professors in programming classes usually haven't done hardly any really serious production programming, and if they have, it hasn't been for a really long time. That's just not where you want to get your information, right? About how to be a production programmer. So, yeah, it's bad, but that's the nature of universities, unfortunately, and that's a fallacy we accidentally created, and it doesn't just apply to programming. It's everything. The place to learn how to do something is not in an abstract studying scenario, and universities were supposed to be for abstract studying, and guilds and apprenticeship was supposed to be to learn how to do stuff, right? And unfortunately, we've lost this dichotomy, and it's a problem. Java is still intro to CS, and oftentimes C++ is barely covered. Why do you think that is? I think it's because a lot of old corporate financial companies in the old guard were stuck with Serverland. Yeah, I don't know why they prefer Java. It's hard to say. I mean, again, like C, C++, they're not good languages either. If you're going to learn something, C is a good language to teach instead of Java for sure. But, there's really no languages I'd point to today and say, wow, that's a great language. We should all be teaching that, right? They're all bad. C++ is awful. And so, the reason I would say why would you be learning Java is because I just don't think you want to teach people things that pretend that the computer is not really a computer, right? Not a good way to learn. But I'd be lying if I said that C++ was some kind of language that I think is great. It's not. I complain about it every day on stream, and just looking at any given piece of my code, I can think of 10 things C++ should have had that would have made it much simpler and much easier to write that piece. All right, it's been a long stream of talking. I'm going to lose my voice. I actually already have lost my voice. So, all right, we all good here? All right. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you want to follow along with the stream at home, you can always pre-order the game on handmadehero.org, and it comes with the source code already. So if you want to play around with it, that's the way to do it. I'm going to be back here tomorrow for more coding. We'll take a look at our memory window and try to get that finished up so that next weekend we can start on our entity improvements. That's about it. Until then, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.